Hello, and welcome to Nokia's Technology Vision webinar on the road to Web3, reimagining the internet. I'm Stefan Kind, Senior Principal at Nokia's Strategy and Technology Organization, and the lead editor for Nokia's Technology Vision. I'm very pleased that you can join us today and hope you will enjoy this great new session. This is the third topic of our 5-episode Technology Vision webinar series. Today, we take a closer look into Web3, blockchain technology, and the power of distributed trust, and how those can be applied. So I'm delighted to be joined for this webinar actually by my two colleagues here, Tom Farkatzem and Thomas Hu. Both Thomas and Tom work as a research scientist at Nokia Bell Labs. And Tom is also an associate professor for computer science at the University of Leuven. So both of them leading our Web3 streams as part of the Technology Vision and sharing some really good insights today with you. So after today's presentation, which will last about 45 minutes, we will have time for Q&A. Please make use of the Q&A function you will find in the bottom of your webinar screen and post questions there. And we can take time at the end and do our best to answer all questions at the end of the session. If you want to look into additional material on this topic, please also take a look at the dedicated Nokia webpage on Web3. You can find the link under resources icon at the bottom of your webinar screen. And with that, and without further ado, Tom, the floor is yours.
All right, fantastic. Thanks so much, Stefan, for the kind introduction. And hello, everyone. Good morning, good afternoon, good evening, depending on where you are. Welcome in this webinar. And indeed, so my name is Tom Farkatzem, and along with my colleague Thomas, both of us in Bell Labs, what we want to do in the next 45 minutes is to really give you an insight into what Web3 technology is, how the technology has been evolving, also explain a little bit our interest from Nokia side in this technology. So I'm going to start by taking a step back and actually trying to define what we mean when we talk about Web3. And of course, when you hear the term Web3, there probably is a Web 2 and a Web 1, right? So let's start with that. So indeed, Web 3 is the natural evolution of the web. The web started out as an information platform somewhere in the early 90s. So the internet by then was already well established, but the web sort of layered, making it much easier to use the internet to share information. So that was the launch of concepts like websites, right? And so what was interesting about the web in its early days, in the early 90s, was that the web was founded on completely open protocols. So these were invented at CERN in Switzerland by Sir Tim Berners-Lee and his colleagues. And so initially to do information sharing between scientists. And so as part of that, they developed a whole suite of open protocols like HTTP, for instance, which were open and standardized and allowed anyone to host a website anywhere. However, even though everyone could theoretically build their own website, it was very difficult for non-technical people to do so. And so therefore, the way that most of us consumed information on the web was in a sort of read-only mode. It's very difficult for non-technical people to contribute information to the web. And that changed with the turn of the century. In the early 2000s, we got the rise of what is today sometimes called Web 2.0. It was a term that was coined by Tim O'Reilly, the owner of the O'Reilly, the well-known books. And so he pointed out that we're no longer living in the early days of the web where most people just read information. With the rise of platforms like Facebook and Twitter, and then later YouTube, and much later Uber, Airbnb, and so on, we allow everyday people to not just be an information consumer, but also easily produce their own content, right? Now, the way in which this is done is no longer built on completely open protocols. Yes, it is layered still on top of the web. We just access these platforms using web browsers. But in fact, these platforms are managed by using proprietary technology that is typically owned and controlled by a single corporation. And therefore, these sort of networks of users are sometimes called corporate networks. But so the web became read-write, and but of course, the the owners of the platforms, they actually took control of most of the data. They own and control all of the data, and ultimately all of the most of the economic value accrues to these platform companies. And so enter Web3 or Web 3.0. So this is a term that was first coined in 2017 by Gavin Wood, one of the co-founders of the Ethereum protocol. And Web3 is all about inventing a new type of network economy based on blockchain technology. And so the first blockchain was Bitcoin, invented around 2008, followed up with successors like Ethereum, and since then many others. And what these networks bring to the web is the fact that you can now own and transfer control of digital assets online. And so this is a property that the web didn't have before. And so people sometimes call Bitcoin, for instance, the TCP IP of money. So TCP IP or HTTP, they are protocols. They shuffle around bits of information or documents, but you can't really shuffle around value. And this is precisely what a blockchain does. It allows you to, using this concept of a token, to represent ownership over some digital asset and to actually transfer that ownership peer-to-peer to other users online. And this gave rise to sort of also new kinds of economies called token economies. Thomas, I believe you wanted to say a few words as well here.
Yeah, sure. Even though it's got 3. So the introduction of tokens, you mentioned, it adds a native payment function, which is missing from both Web 1 and Web 2. So I think this is a significant step forward. Now, for the current Web 2, which is dominated mostly by the hyperscalers, Web 3 is actually going back to the more decentralized model of the internet, which is like Web 1, where the sites were authored and hosted by individuals and enterprises. So this re-empowering of users is a very good step backward.
All right, thanks. So now, why are we interested in Web3 today? Because it's actually a technology that has been maturing for, let's say, the last 10, 15 years, but it's become increasingly relevant given recent geopolitical tensions, in particular, because what we notice is that trust in centralized institutions is under assault, whether this be trust in governments, but also trusts in large corporations. And indeed, the large internet platforms have been under quite some scrutiny, especially in Europe from the regulators. So there is this push for more transparency and more decentralization. The other thing is simply that Web3 technology, for the first time, enables us not to digitize our data, but also our identity and scarce digital properties. So this is just a natural evolution. We are digitizing everything, and with Web3 technology, we can now also digitize ownership. So all of that said, though, you may have heard some very controversial things about Web3. So like with any technology, it can be used to good or ill effect. And so you have very loud proponents and you have very loud skeptics. And so the proponents, they will tell you that Web3 is the solution to finally break us out of this, these large platform economies where sort of the internet economy is dominated by a few companies that sort of own and control all the important platforms. You will also hear them say that, okay, blockchain technology allows us to put less trust in humans and institutions. We can put our trust in the mathematics and the protocols, and also that it will enable the end users, the actual content creators, to accrue more of the value rather than leaving most of the value to the platforms. Now, on the opposite side, you have the skeptics, and the skeptics will tell you, okay, this blockchain and all these cryptocurrencies built on blockchain, it's all about speculation. There is no intrinsic value. There's even outright scams, right, where people are just in it for stealing your money. They will call out that blockchains are very inefficient, also very energy inefficient. And the reality is probably somewhere in between. As with everything, right? It is not all good and not all bad. And so let's try in the coming 40 minutes or so to hopefully paint a bit of a more nuanced picture of Web3, its capabilities, and sort of the emerging concepts. Now, so to start with, let's actually talk a little bit about, from a technology point of view, what is so special or novel about Web3 compared to the way Web2 systems have been built, or are still being built. And I think it's best to use an example to illustrate this. And let me use the example actually of, for instance, a service that most of us know, like Facebook, for instance, right? So Facebook is a traditional Web2 system. It's a corporate network, and it's, of course, wholly owned and operated by Meta, right? And if you would draw sort of a high-level schematic of the architecture of a platform like Facebook, you would see that, okay, there's many users of the service, and these users, in order to use the service, they have to authenticate with Meta. And Meta is the single service provider that will host and operate this Facebook service. And of course, within this service, Meta will have to keep a big database of all of the credentials of all of its users, because as you know, when you want to authenticate with Facebook, you have to create an account, you have to log in. So all of the identity data is actually stored on the platform with them. Of course, they also store all of the user data. If you upload pieces of text, if you upload images, that's all stored and owned on their servers. I think most people by now are very much aware of that fact. What you may not be that aware of, but it's equally important, is that Facebook also completely owns and controls all of the service logic, the code, the actual software that makes the platform tick. For instance, just think about the AI algorithms that decide what are the feeds, what are the posts that you are going to see in your personal feed. This is determined by an AI algorithm that runs on their servers that is quite black box for the users. As an end user, you don't sort of have any insight into that algorithm. You don't get to control it, much less change it, okay? So if you contrast this now with Web3, a blockchain network, it operates by very different principles. And as you can already see in the figure on the bottom right, the most important difference is that a Web3 service, a true Web3 service, is operated not by one entity, but by many entities, many independent entities. So here we draw a little network. In reality, you might have hundreds, maybe even thousands of individual nodes in this network that all operate, let's say, a copy of the service. And as you can see, the database of data is copied around. This is typically called the blockchain. It's just a big replicated database. And also all the logic, the service logic of the service is also copied and executed by all of these parties. And this is actually where blockchain gets most of its security benefits, is because everybody all the time is checking everything. You can sort of rule out bad actors as long as they are in the minority. If there's one or two of these nodes that try to change the rules to their advantage, then the majority of the network will notice that they're not following the same rules that were agreed upon by the community, and they will be sort of ignored. So this is the basic principle of blockchain. The other thing that you can take away from this figure is that the keys reside with the users. So this is another big difference in a pure Web3 service. The users have control of their cryptographic keys. And so it's not the operator that owns and controls the user accounts. It's the users that have self-custody of their account. And they have to authenticate all of the actions by signing using digital signatures. They can sign all the updates they want to make to their data. And then these parties in the network, they will verify this. Okay, so this is essentially a paradigm. Web3 is a paradigm shift in how you build and operate backends of websites. Now, Web3 is a technology, and like any technology, you often have quite a complex technology stack, right? So let's very briefly summarize the Web3 tech stack. So at the very bottom of the stack, blockchain is built on cryptographic algorithms. So I just mentioned digital signatures. There's also cryptographic hash functions. There are these what are called consensus protocols or Byzantine consensus protocols, and many others. And I will not go into any detail in this presentation, but the bottom line here is that underneath all of these sort of the hype of blockchain, there are very solid cryptographic algorithms that are actually been battle tested for the last decades. So many of these cryptographic techniques are not novel. They have been invented in the 70s and have been hardened in the previous decades. And the key takeaway is that when you use these algorithms, you put your trust in basically the mathematics rather than having to trust another person or an institution to do the right thing. Okay. So on top of these foundations, people have built all kinds of protocols, and the most important ones are these blockchain protocols. So a blockchain is kind of like a distributed database, a distributed ledger, if you will, and they operate by replicating data over what's called a peer-to-peer network. So peer-to-peer means there is no single central, it's not a hub and spoke architecture. There is no single central point of control or central point of failure. And on top of blockchains, people have invented new concepts. And I already mentioned earlier the token, the notion of a token. So this is a new abstraction enabled by blockchain technology, which can represent anything. So originally, so the first cryptographic token, like Bitcoin, represented the kind of currency. People have invented, you've probably heard of NFTs or non-fungible tokens, which represent like a unique property right that is tied to a unique piece of digital property. It's often closely associated with art, but the technology itself is not tied to art per se. It's just you could as well use it to represent, for instance, ownership of intellectual property rights or voting rights in the protocol. So there's every few years, somebody smart seems to come up with a new use of tokens, essentially. And finally, using these tokens, people build new types of applications. And so what we're going to do in the next 30 minutes is to review what we think are the most established and promising application areas in Web3. And so we're going to start by talking about an application area called Decentralized Finance, or DeFi. Then we're going to talk about decentralizing social media, that's called DeSo. Then about decentralizing governance using DAOs, decentralizing physical infrastructure networks, or DePINs, and finally, the tokenization of real world assets, RWA. So these are 5 big sort of sub areas of Web3, if you will. If you take any of these keywords and you Google them, you will probably find lots of material. So let's try to sort of break this down and give you a high level overview. Okay, and we're going to start with DeFi. And DeFi, or decentralized finance, is probably the oldest and most established application area in Web3 by far. So what is it all about? Well, as you can see in this graphic on the right-hand side, is what we call CeFi, or centralized finance, traditional finance. And what a thing that is very common in traditional finance, when you want to do any kind of financial transaction between two parties that don't fully trust each other, is that you use a trusted intermediary. And we know these intermediaries as the banks, or the notaries, or governments, or a payment processor like a Visa or a PayPal. And all of these intermediaries, so they are there to establish trust in this transaction. Could be a payment transaction, could be taking out a loan, all of these kind of things. So what DeFi tries to do is it tries to get rid of this central trusted party by moving all of the trust onto blockchain-based protocols. So you still have to trust the blockchain technology, but if you trust the technology, you don't need to trust any particular individual or institution. And then in some sense, if you think of the blockchain as a kind of technology substrate, then what it allows people to do is to transact with each other peer-to-peer without any centralized institution in the middle. So this is the goal of DeFi. And so we're talking things like making a payment, but also taking out a loan, borrowing assets, buying securities, making a trade, all of these kinds of things, like anything you can do in a traditional financial system. Now, when we say like, okay, we have to trust the blockchain, so how does that actually work? Well, a key technology building block in DeFi is what are called smart contracts. So smart contracts, you may have heard of the term. What they actually are simply little pieces of computer code, computer programs that are stored on and executed by these blockchain networks. So if you think back to service logic in the Facebook example, so this service logic, this is actually what you program with smart contracts. And once you deploy such a piece of code on the blockchain, once it is deployed, you can no longer change it. Even the original author of the code cannot just change it at will, which means that if everybody agrees and has reviewed this piece of logic, and if they all agree that it does what it's supposed to do, then you no longer need to trust anyone. You can trust that the blockchain will execute those rules as stated. Okay, and so the way this then works is if, let's say, Alice and Bob want to transact, but they don't fully trust each other, but they do trust a smart contract, then what they can do is they can transfer their assets or their data into this smart contract. And the contract at that point has control over those assets, and it can execute logic. And this is not like AI code. This is typically just very simple if then else rules, traditional programming logic that can decide, if both parties have agreed to their side of the bargain. And if they have agreed, then the smart contract can start moving out these funds to pre-agreed destinations. And this is how you sort of get trust. So it's kind of like, think of the smart contract as a kind of trusted escrow, right? That can keep assets in escrow until all the conditions are met to release the data or the assets. A quick word about the term. So smart contract, it's not smart as in using AI. As I already mentioned, it's typically just very traditional programming logic. And it's also not a contract in the legal sense, although this is actually changing. So we are seeing some jurisdictions acknowledge smart contracts as a legally binding agreement. We are seeing regulations, for instance, the EU Data Act, very recent, that is acknowledging the existence of smart contracts. So this is actually, the legal system is kind of catching up with these innovations as we move forward. So using these smart contracts, people have built many different types of services, too many to address in this short overview. We'll just zoom in on a few that we think are the most innovative: decentralized exchanges, stable coins, and prediction markets. So decentralized exchanges, or DEXs, as the name implies, what it actually does is it uses smart contracts to build essentially the decentralized equivalent of a traditional stock exchange. So in a traditional stock exchange, you have buyers and sellers, and you have a market maker that has an order book, and they will determine what is the price, for instance, of a stock. But you have to trust the market maker to do this correctly, right? So what people have done is they have coded up the logic of how to set the price using smart contracts so that the price can be set completely algorithmically, automatically, without having to involve a trusted third party. And as one example, Uniswap, for instance, is one of the largest decentralized exchanges in the world today. And its smart contracts trade over $5 billion worth of digital assets, and they have a trading volume of over $2 trillion in the last few years. So this is it's still small, maybe compared to the traditional big stock exchanges, but it's also not negligible anymore. So there's a significant amount of trading that is happening on these platforms. A second key innovation that's happened, that's sort of taken the world very rapidly in the last 2-3 years, is stablecoins. So people, when they think about blockchains, tokens, cryptocurrencies, they will often say, but this is not very useful because the value of these tokens changes very dramatically. And of course, everybody is familiar with how, for instance, Bitcoin has risen from having no value at all to over $100,000 in the last months. And so indeed, this volatility is a big problem for a lot of financial use cases. So what people have done is they've created stablecoins, and stablecoins are a type of cryptocurrency. It's a token on a blockchain that is backed or pegged one-to-one to traditional fiat currency like US dollar or euro. And so the way it works is you have a company or an organization or a group of companies that pledge to, for every token that they create on the blockchain, they will also hold, for instance, $1 on their balance sheet. And you can use traditional financial auditors to confirm that they indeed hold the amount of dollars on their balance sheet that they claim to have emitted. And so if you trust that company, you can trust their tokens, and the tokens themselves, they typically trade one-to-one with, for instance, the dollar. The chart on the right here shows in the last few years the tremendous blow up in total value that has been created in stablecoin currencies. And interestingly, it's not governments that create these tokens; it's often private companies. Even, for instance, the PayPal, one of the big internet payment giants, has created their own stablecoin last year. And the final trend that we want to spotlight in DeFi is prediction markets. So what are prediction markets? They're essentially a way to use the blockchain and the token concept to create a sort of betting market or prediction market on future events. So, for instance, let's say you're interested to know the outcome of the US presidential elections. It was a big event, of course, that we had last year. Maybe a more current example is you want to bet on who the new pope will be, right? But essentially, there's plenty of events that individuals and companies are interested in having accurate predictions for. And so what a prediction market does is, for any event, it can create a pair of tokens. And the pair of tokens originally starts out at an equilibrium. Both tokens are worth the same amount of value. But as time moves on, one of these tokens represents, let's say, the outcome that the one candidate wins the election, the other token represents that the other candidate wins the election. And as time moves forward, these tokens will trade at different prices, but the total value of the token will always be 1. So you can interpret the price of the token as a probability that what the market believes will be the outcome of the event. And so in the end, when you make a prediction using these platforms, you have money. You have skin in the game, in some sense, financial skin in the game on the outcome of the event. And so there's, of course, these prediction markets, they are not new. What is new is that traditionally you had to trust one party with that had to collect all of these funds, and you had to trust them to actually do a truthful reporting on the outcome. And so what's happening with Web3 is we are replacing all of that trust in a centralized platform with trust in code that runs on the blockchain, smart contracts, essentially. And so as one data point here, and so I mentioned the presidential elections, and indeed, so this is a chart here that shows the value of the two candidates, the tokens representing the two candidates in the US presidential election on a Web3 betting platform called Polymarket. And it was the largest prediction market in Web3 to date. So people have computed that over $3.6 billion worth of value has been sort of placed in bets on this particular outcome. And if you compare that to the traditional non-Web3 betting markets, they accrued roughly $300 million for the same event. So that tells you that for prediction markets, clearly Web3 is bringing something new. People are massively moving to these newer types of platforms. Thomas, I believe you also had a few words to say about these types of platforms.
Yeah. So I am very excited about the Polymarket. I think this is actually one of the most interesting services that came out of DeFi. Now, I like it not because I like to gamble. Rather, I believe a finance-based prediction market actually provides the most informed opinion about an outcome. It seems that the strong desire not to lose money can really pull out the true wisdom of the crowd. And in fact, there are some recent studies that show Polymarket is about 90% accurate on predictions about 1 month from the event. And the accuracy goes up even further as it approaches the event. So it outperforms traditional polls and expert opinion. In fact, for your example of the US election, the final outcome on the Polymarket actually matched much better to the actual result than all the polls and all the experts. So as the old saying goes, money talks. Now, unfortunately, even at this point, I think Polymarket is still not available to US residents due to regulation. I'll also make a quick comment on the stablecoin. There's a recent report that came out in early 2025. I think the stablecoin transfer volume now has reached 27 trillion. This is actually more than Visa and MasterCard combined. Now, this is significant because stablecoin came into the scene only in around 2016. So this 0 to 27 trillion happened in just about 7 years. I think stablecoin is likely going to become the future of global digital payment. And also in recent years, there has been a lot of talk about de-dollarization. And in fact, now is even more now because of tariff and all that stuff. I think the success of stablecoin may actually reverse that trend because most of the stablecoins are pegged to US dollar. I think Tether is number 1 and USDC is number 2. So the success of stablecoin may actually help US dollar to remain the sort of global reserve currency.
Correct. Yep. Good observations. Thanks. All right. So with that, we're going to wrap up the part on DeFi. As I said before, this is the largest and most established area where Web3 technology has been used. So the other application areas we're going to cover, we're going to be more brief. And also, this is definitely also a much more emerging area where we haven't yet seen these large numbers and large impact. So the first of these is decentralizing social media. So what is this all about? So you all, of course, are very familiar with social media. It's there in every facet of our lives, but you are also very much aware that all of the social media platforms today, the ones with a lot of reach, are in fact operated by the large corporations. So we have X, formerly Twitter, we have Meta that runs them, we have Google, of course, with YouTube and others. So given the importance of social media in, for instance, also the public debate, in politics, elections, a lot of people, of course, have questioned this, like, should we leave control of these very important media channels to a few corporates? And so people have tried to come up with ways to decentralize these services. And in particular, it already starts with like a split up of splitting, let's say, the servers where the data lives and the apps or the interfaces that people use to access that data. And so today, the app and the server, it's all centralized. It's all sort of operated and provided to you by a single party. And there are many initiatives where people are trying to decentralize this in different ways, and not all of them using purely Web3 technology. So for instance, one technique that people have tried to use is to say, well, if only we had open protocols and standards, we could let people just choose the server where they want to create their social media account. Maybe you've heard of ActivityPub. It's a common protocol for that, or Mastodon. So there exist hundreds of Mastodon servers that you can choose from. You can join any of these servers, but you can still follow the people that have an account on another server. So this is what's typically called the federation model. And it works well, except that there isn't really like a single overarching service. Search doesn't really work very well across all of these servers. And in fact, the moderation policy might be completely different among any of these islands, if you will. And to combat that, there have been some companies that have worked on leveraging blockchain technology, Web3 technology, to actually store the most important data, which is the social graph. So the entities and the people who is following whom, to actually store this on a blockchain. So to make this something that is replicated, that people cannot tamper with, so that there is a single unified social graph. And this is, for instance, the approach taken by companies like Farcaster. And then there is an even more extreme case, which is a pure peer-to-peer case where people are saying, I should be able to just host my own data, and like every user is their own island, if you will, but these are facing significant scaling issues as you scale up the number of users. So what we have observed in let's say last year, with all of the turmoil, I think, happening at X, formerly Twitter, of course, with Elon on board, there was a very clear case of a certain part of the community that was operating on this platform that did not agree to all of the changes that were happening on the platform. And so people have clearly been exploring alternatives, and one of the more popular alternatives is Blue Sky. So Blue Sky is a alternative social platform that promises that users can actually choose their own backend, even though today the most popular backend is one that is actually operated by Blue Sky as a company. I believe they're a UK-based company. But it's interesting if you look at the trends, they experienced tremendous year-over-year growth last year, and they even overtook Threads, which is Meta's answer to X. But Thomas, I believe you had a few remarks on this as well.
Yeah. I think DSO is a very interesting space. I think if DSO succeeds, it can potentially help jumpstart many other decentralized projects. Now, your graph shows that Blue Sky has crossed 30 million registered users, but that's still about, I think, less than 5% of X. Mm-hmm. And if you look at the daily active user, actually the difference is much bigger. I think the Blue Sky daily active user is about like 3.5 million. X is about 300 million, so that's 100 times. And also, there's a lot of political factor behind the rise of Blue Sky. Like people just maybe they don't like Elon Musk so much, so they're dumping X. So I think we need to be careful to separate out those factors from the real changing attitude towards decentralized applications.
Mm-hmm. Yeah, fair point. Absolutely. Okay, so with that, let's move on to another sort of key application area, one that, in fact, we at Nokia are very closely engaged in and watching. And this is the area of decentralized physical infrastructure networks, or DePIN projects. So what is this all about? Well, so DePINs are about combining blockchain technology with physical infrastructure, often in the digital domain. And when we say physical infrastructure, you should think about things like servers that have actual compute power to offer, or storage space, disk storage, or if you think about a communications network, hotspots that can actually, provide spectrum to end users in order to communicate. And so another way you can describe these services is what they try to do is to build traditional, let's say, compute infrastructure or communications infrastructure, but rather than having one party build out buy all the equipment, put it in one data center, and then operate the service, they will try to leverage blockchain to get smaller players, individuals or small companies, to each contribute a small amount of resources to a single platform and to get rewarded for contributing those resources. So think of it kind of like an Uber, Airbnb model for digital infrastructure. And so typically blockchain is leveraged both for users to actually pay for the resources that they use, so as a payment, but also as a reward mechanism. So you can reward people that actually contribute more resources, they will earn more rewards. And also finally, as a way of doing governance, like if you want to change the rules of the system, you can put it to a vote, let people vote using the blockchain to decide how to move the system forward. Some key elements of these platforms, or ways that they try to differentiate themselves from more traditional centralized digital infrastructure, is that they claim higher levels of transparency, higher levels of censorship resistance, a lower barrier to entry for small players, and a way to sort of avoid having to raise a large amount of capital so that not one party has to do all of the capital expenditure for buying all of that equipment, but instead you're sort of spreading it across the crowd. So as I said, DePIN can be applied to any digital service, computation, storage, communication, and so on and so forth. We are specifically also interested in how it may affect communication technology. And so there is a sub area within DePIN called DY, or Decentralized Wireless Networks. And the way this works is exactly as you might expect, is in a traditional wireless network, you have a large operator that will do the capital expenditure to put a lot of cell towers and host a service. But in a DY system, instead you want to transition to many independent parties that each contribute maybe small amounts of hardware, but that will all be linked together using a backend system that typically leverages blockchain as well, to make one single seamless service out of these smaller parts. If you want to do that for true wireless, like for mobile internet, of course you need spectrum. And so that's clearly a high regulated area. So how does that actually work? Well, in the US, for instance, we have seen the rise of open spectrum solutions like CBRS that actually do allow small companies or individuals to use their own spectrum. There's been the rise of open source components that allow you to actually host 3GPP compliant software so that you can actually serve devices. And then finally, of course, there's the rise of blockchains like Ethereum, Solana, and so on that actually provide very open identity and payment infrastructure that you can leverage instead of the traditional like SIM and so on. So these are all technology building blocks that allow you to build networks very differently from how they are traditionally built. And in order to make this a little bit more concrete, we can actually sort of dive into a small case study here. And that case study is Helium. So if you haven't heard of Helium before, they are probably one of the largest DePIN projects to date. And so their goal or their vision is to build a decentralized communications network. Their original vision when they started out as a small scale startup was to do this for IoT networks. And in fact, they started off with this quite niche communications protocol called LoRaWAN. So LoRaWAN is kind of like, think of it as like Wi-Fi, but with much longer range, and much lower bandwidth. So it's sort of designed to just transmit small packets of data, for instance, from some IoT device that needs to just send small packets of data back to a backend. So it's sort of ideal for IoT sensing, if you will. And so what Helium tried to do is they had this model where they would essentially sell what they called hotspots, which are just these little devices that you can put in your home, and they would provide coverage for a few miles around your home, and any IoT device that would connect to your hotspot could use your home internet connection to backhaul internet traffic, these sort of small packets of information, and you would actually get rewarded for that using crypto tokens called HNT, or Helium Network token. And of course, the price of HNT in US dollars was very volatile, like with most of these cryptocurrencies. And when they originally launched this, they actually got a lot of traction. So there was a lot of sort of word of mouth. The price of this token went up. That caused even more people to sign up, which caused the price of the token to rise even more. So you had this flywheel effect. And indeed, very rapidly, actually, it's quite impressive that in just under 2 years, they went from 0 to over 1 million of these hotspots deployed worldwide. So they actually had global coverage. So this was actually the very first global IoT network, because traditionally these networks are operated also by CSPs, but they're very regional. Like every region has its own, and they created this sort of global one. Unfortunately, the whole model collapsed because it wasn't sustainable. In particular, while there was a big increase in the supply of the network, there was not a similar increase in the demand for the network, meaning more devices that connect to the network and actually pay pay enough fees to get this to get this system running. And as a result, we got a sort of, you saw a collapse in the rewards that people got. Therefore, after a while, a lot of people that originally invested in this network actually left, and left the system in a bit of a uncertain state. So of course, Helium, they actually pivoted since then. One of the things they realized is that, okay, clearly the case for a worldwide IoT network was not proven, so there was not enough demand. So they pivoted to more traditional wireless protocols like Wi-Fi and also 5G, so traditional wireless internet. And also they moved from their own bespoke blockchain, with which they actually suffered a lot of outages because they couldn't deal with the scale up. They transitioned to general purpose blockchains like Solana, which you may have heard of. It's one of the top blockchain projects today, and it's especially known for its low fees and very high throughput. So it's a very high performance blockchain. And so today, what Helium is trying to do is they are trying to do this game again, but with building out a 5G network in this decentralized manner. And it's still very early days. So yes, we are seeing that they are building out, but we haven't yet seen this sort of exponential traction that we have seen with their IoT network. So that's the key question, right? Like, can you actually repeat that success, that flywheel for 5G? That's if they would manage to do that, that would of course be a big deal. Okay, so now we've talked a lot about communication, but in fact, at Bell Labs, we are also engaged in some DePIN projects ourselves, but in another area. And Thomas, I will let you talk a little bit about this, the projects that we have.
Yeah, thanks. I think the same approach of Helium can be applied to decentralize many other physical resources. I think the compute is obviously one of them. But at this point now, instead of general compute, like giving my computer for others to use, I think GPU compute is particularly much more interesting now, just because the AI needs an enormous amount of compute in the future. So we have a project in Bell Labs working on decentralized AI. So it's called Our AI. So we are creating a platform that allows users to contribute resources for AI computation. So you can imagine such a platform to be useful both within an enterprise, like within Nokia itself, as well as on the open internet. So we believe decentralized AI can lead to democratic AI. So as a society, we can't have AI just in the hands of a few sort of monopolies. So decentralized AI put AI back in the hands of individuals. So this Our AI project is an ongoing research project. Maybe stay tuned. We may report more about it in the future.
Great. All right. So looking at the time here, I think we need to maybe speed up a bit and not cover the other topics in that much depth, but just briefly on DAOs. So DAOs are about leveraging blockchain technology to let a community of people that might not actually all trust each other still kind of sort of engage with one voice. And so rather than having to have like a traditional setup where there is one leader or a CEO and decisions are driven top down, you get a community where people can make proposals and then they can vote on these proposals backed by blockchain to make sure that everybody can only vote once. And you can use this, for instance, to do fund allocation. A great example, I think, to just mention one is Gitcoin. So Gitcoin is a DAO that tries to allocate funds to open source projects. So this is the perennial problem with open source. Like everybody uses it, but who actually pays for it? And how should you decide which project gets, which of these hundreds or thousands of open source projects should get how much funding? So Gitcoin is actually a project to let the community allocate funds for that. It's quite interesting. Thomas, I think you had a comment also on DAO.
Yeah, sure. I think the term autonomous remind me of all the hype around AI agents at this point. So there's a lot of the talk recently about autonomous AI agents that can perform tasks on its own without a human in the loop. So you can imagine, so a bunch of these agents can come together as a crew in a multi-agent setting. And then on top of that, you can imagine using this concept of DAO to apply this sort of like an AI agent crew to truly form a autonomous organization with autonomous AI agents. So that seems pretty wild, but definitely feasible.
Great. So let me just skip through the final one, or just really quickly maybe mention one thing about RWA. So RWA, or tokenization of real world assets, is simply the idea that rather than tokenizing purely digital things like currency or like voting rights or something like that, you actually want to tokenize ownership of real world things like real estate or cars or things like that. In fact, there's this interesting piece of news from last year where the California DMV actually digitized or tokenized all the car titles that were registered with them on the blockchain. And the benefit of this is that you actually improve both the provenance of ownership. You can have fractional ownership. You can have you can start trading these things. So this is a trend, as you can see on the figure on the right, that has been really booming in the last years. Thomas, any final comments on that one?
Yeah. So RWA, or real world asset, is such a practical concept. Like I don't understand why this is not already happening in a much bigger scale. So for example, one application comes to my mind immediately. We hire a lot of people, like full-time researchers, summer interns, contractors. Up to now, we use transcript, which is basically a PDF file. With Gen AI, you can easily like fake transcript and all that stuff. A simple solution is you can imagine these real world, like these transcript could be sort of tokenized and put on the blockchain. Now anyone can easily verify them. So again, correct. I hope things like that can really take off very soon.
Thanks. So time to wrap up. So what we did in this brief presentation is to give you a glimpse at the emerging application, well, established and emerging application areas in Web3. Maybe as a final comment, so clearly Web3 has grown tremendously in the last 10 years, but if you compare it to traditional Web2, it's still actually quite small, right? So Web3 is actually still quite small compared to Web3. And in fact, actually, we believe that this is probably not going to change much. So some people think because Web3 is called Web3, it's going to replace Web2. But honestly, we don't think that there's going to be any kind of replacement. Instead, just like Web2 also didn't kill like small-scale websites, Web3 is not going to kill the big platforms. Instead, what we're going to see is a parallel economy that's going to grow, and the two are going to coexist. Some people call this Web5, like Web2 plus Web3. But that's the bottom line. So we're going to see this coexistence. Now, the other big question is within Web3, DeFi clearly today is where most of the value is and most of the applications are. And it's worth questioning whether that will still be the case, let's say 5 years from now, right? Is DeFi going to remain the killer app? Or are these other emerging areas that we have highlighted, is any of them actually going to break through? And if so, that's probably going to have a much bigger effect on sort of the end user adoption of this technology. Thomas, any final words from your end?
Yeah, so I think both Web 2 and Web 3 will be growing. So they will be growing. So we'll be living with Web 5 for a little while. Mm-hmm. And the last point that I want to mention is, I think you put at the beginning, there's been a lot of controversies or speculative issues around Web3 because of crypto scams, meme cons, and also we have the NFT craze. But believe all that stuff, though, there are some very real and interesting technology. For example, the blockchains is real. The smart contracts are real. So personally, I believe that as we move more and more towards a digital society, the issue of trust will become more and more critical going forward. I think blockchains smart contracts, technology like that are what you can leverage to enable sort of trustless interaction in this new digital society.
Fantastic. Thanks, Thomas. And with that, Stefan, we're going to turn it back to you. We are done. Thanks a lot for your interest, and let's maybe answer a few questions.
Yeah, thanks to both of you. Very interesting presentation, and also quite, I think, good to see the different application areas and we are probably just scratching the surface. I think there was one question almost answered, I think, Thomas, by you, which came in at the very end. This seems to be all very early stage. What is the expected timeline to see more applications to gain substantial market traction? I guess it's a bit of a speculation, and you, as you already said, for the last topic, that you would have expected better market traction already. So, what are the blocking points? Probably this could be then key point here. Are there any obvious blocking points, or is it just the normal technology adoption?
I think there are a few blocking points, and people have often pointed to the poor user experience of Web3 protocols, in particular the fact that, I mentioned this idea of like users have the keys, right? So users control the keys. You don't need to trust the platform, but there's a lot of friction that goes into that, right? Like if anyone has ever tried to install like what's called a Web3 wallet, which is the actual software that you use to actually manage these keys, it's a real pain. It creates friction. It creates additional steps people have to take in order to interact with services. So what actually ended up happening in practice is that often people just interact with these Web3 protocols through a traditional Web2 website, right? And I think that the clearest example of this is actually, most people will know Coinbase, right? So Coinbase is a company where you can make an account. It's just a very traditional website, but then through that website, you can interact with all kinds of Web3 protocols without actually having to set up all of these keys. But then the downside, or the thing that many people are not aware of, is that you also lose the self-custody aspect, right? You actually have to trust that intermediary to manage your funds, and like if something happens to that company, there will be implications for your ownership and so on and so forth. So I do think the UX issue of like the self-custody, the managing your own keys is an important hurdle that in some application areas has been overcome more successfully than in others. For instance, clearly, when it comes to money and trading, people will be more willing to actually put up with all of this stuff and extra security than with social media, right? Like social media, people just want to create an account and just want to post, and they don't want to have to deal with all of this stuff. And so you definitely do see that friction there. I don't know, Thomas, if you have anything to add.
Yeah, I think we are on top of the hour. Thanks, Tom. Unfortunately, I see a couple of other questions still coming in, but please feel free also to reach out to us. Some of them actually, I think, are even addressed on our webpage. So many thanks to both of you again. I think otherwise we would be running over. Thanks for everyone joining in today. I hope you enjoyed the session. So let's stop here. Just a note, if you can provide us some feedback on the session, the link is in the window below as well. And please stay tuned for next week's Technology Vision Deep Dive webinar on spatial computing, another very interesting application area. So if you haven't registered, please be sure to either use the link here, or otherwise you will also find the link on our webpage. The easiest one is just taking a picture of the QR code here. So with that, many thanks again to our two speakers and to you as an audience, and see you next week. Bye-bye.